Okay, hello everyone. So this is my second video on my YouTube channel, and in this video we are going to talk about the order properties of the set of real numbers. And in this, the order properties are mainly of three types. The first one is the algebraic properties, the second one is the order set properties, and the third one is the completeness property. So let us start with the first one, the algebraic property. So here, as you can see, the algebraic properties are of three types. The first one is additive properties, that is addition, and the second one is the multiplication, and the third one is the distributive. So for the just to make an attempt to make these learning of these properties easier, I have divided these properties into four parts. Like addition property has these four subparts in it, and the multiplication has these four subparts in it, and it will make it easier for you to learn this way, as the first two properties, that is commutative and associative, are similar in both of these additive and multiplicative properties. And in this, the additive, the third property is the existence of zero element, and in multiplicative it will be the existence of unity, that is 1. And in the fourth property of additive would be existence of negative element, and in the multiplicative it would be the existence of reciprocals. So let me start telling you like what does it exactly mean. So the as we know, commutative property is in addition would be let a and b belong to real numbers. Then the commutative property states that if we add a plus b, then a plus b would be equal to b plus a. Similarly, in multiplicative commutative property will state that AB would be equal to BA. And now the associative property will say that if A and B and C are some real numbers, then A plus B plus C would be equal to, if we add A plus B together and plus C, so these both things will be equal. Similarly, in multiplication, associative property states that A B dot C would be equal to A dot BC. And now the third property is existence of zero element, and it states that if we add 0 to any element, then it will give us the element itself. Okay, similarly existence of unity in here, that if we multiply 1 with any element, then what we'll get is the element itself. Okay, now I'm going to talk about the fourth property, that is existence of negative element. It means that if we add an element and then we add its inverse, the negative of the element, then the answer that we'll get will be 0. Like here, if a and minus a belongs to real number line, then a plus minus a is equal to 0. And the existence of reciprocal states that if we multiply a number with its reciprocal, then the answer that we'll get would be the unity. So these were our two properties, addition and multiplication. And now let's talk about the third one, that is distributive. So distributive property is nothing but just the combination of additive and multiplication property. So distributive property is a into b plus c would be equal to a dot b plus a dot c. Similarly, b plus c dot a would be equal to ba plus c dot a for all a comma b comma c belongs to R. So these were our algebraic properties. So now let's move on to the second property of real numbers, that is the order properties. So the order property states that if there is a subset P of real numbers such that P is a set of all the positive numbers, then either of them is true. That if A comma B belongs to P, then A plus B also belongs to P. And if A comma B belongs to P, then the product A dot B will also belong to P. And now the third and the fourth, most important property states that if A belongs to R, then any one of the following holds. And what are these? Number one, that A belongs to P. That means that A is a positive number, or A is equal to 0, or minus a belongs to P. And it is quite obvious that a number that belongs to real number, that can either be positive or negative or 0. And this property, that is the most important one, it's also known as by the term trichotomy law. The students who have actually studied real analysis know about this trichotomy law, and this trichotomy law is nothing else but this thing, the third point, where it states that a number can either be positive or negative or zero. If the number is in real numbers, it can neither be any two of these. So this is the law of trichotomy. And now this order properties has some of the theorems that whose proofs are not important, but these theorems you should know, you must know in fact. And so the first one is that if a is greater than b and b is greater than c, then a is definitely greater than c. The second one is that if a is greater than b and we add c on both the sides, then obviously a plus c would be greater than b plus c. And the third one is that if a is greater than b, then if we and c is greater than 0, and if we multiply c both on both the sides, then ca would be greater than cb. And if the c is less than 0, then the signs will reverse and ca would be less than cb. So these were some of the order properties, and now let's move on to the last and the third most property, that is the completeness property of R. So the completeness property of R states that every non-empty set of real numbers that has an upper bound has a supremum in R. I know you guys might be finding some trouble in understanding this third property because you are not able to understand the terms like the upper bound or the supremum. So let me first explain what does these terms mean. So for that, let us take a set S in the set of real numbers. So the set S can either be upper bounded, or it can be lower bounded, or it can be the bounded set. So the set will be known as upper bounded if let element u belongs to S such that for all x belonging to S, so u will be greater than or equal to x, then u is known as the upper bound of S. Like let all the x belonging to S, though if there is an element that is greater than all the x's or it is equal to all the x's, then u is known as the upper bound of S. Similarly, if u belongs to S such that all x belongs to S, then and u is less than or equal to x, then u will be known as the lower bound of S. And the third one, the bounded set. The bounded set is nothing but if it has both of them. Like if a set is bounded above and it is bounded below, then the set is known as to be a bounded set. So now let us talk about some important terms that are supremum and infimum. So these terms are also not tough. It's just let us take the number line R and let us take a set S which has these four elements. Then we can say, like we have studied about the upper bound, so all these members that I have marked with the line, then they all will be the upper bound of this element. Obviously because they all are greater than this element, so they all are the upper bound of this set S, and these all will be the lower bounds of this set. So the number element this of S, it will be known as a supremum of R because this is the lowest upper bound of the set R for the set S. So in this set S, this number is the lowest upper bound, and the lowest upper bound is known as the supremum. And similarly, if we talk about this element, then this element is the greatest lower bound, we can see, because these all are the lower bounds and this is the greater one. So this is the greatest of all of them, so this will be the greatest lower bound and hence the infimum of R. So I think you all are done through with the concept of supremum and infimum, and if not, then I'll be discussing these concepts in more details in my further next videos, because supremum and infimum are very important topics that you really need to understand. So in my next video I'll be doing some questions